Hey everyone, and welcome to our deep dive all about architecting your own data warehouse on AWS. We're going to be taking a look at how we can use Redshift Serverless and Glue to build something really powerful, scalable, and efficient.
Yeah, and I think it'll be super insightful for you guys listening because we're going to tailor this whole discussion around what you actually need. We'll cover architectural considerations, best practices for loading your data, and even some optimization techniques for Redshift Serverless.
Awesome. So first things first, can you give us a little rundown of what Amazon Redshift is and what makes it so good for building a data warehouse?
So, Amazon Redshift is a fully managed petabyte scale data warehouse service. It's in the cloud. Think of it as a high performance engine that's made to handle a ton of data and run those complex queries. And the best part is that because it's fully managed, you don't have to worry about setting up or maintaining the servers yourself. AWS handles all that for you.
Wow, that's super convenient.
Hmm.
So I can spend more time focusing on actually analyzing my data and getting insights rather than messing around with infrastructure. But what about the architecture of Redshift? How does it actually work?
Okay, so at the core, a Redshift cluster has a leader node and then a bunch of compute nodes. The leader node is kind of like the director. It handles all the client connections and distributes tasks to the compute nodes. The compute nodes are where all the heavy lifting happens. They're the ones actually processing the data.
So it's like a team. You've got the leader delegating tasks and then the workers who get it all done. But how does all that data actually get distributed across those compute nodes?
So that's where slices come in. Each compute node is divided into these slices, and data is spread across them to enable parallel processing. This parallel processing is a huge part of what allows Redshift to get such great performance, especially when you're working with tons of data.
So basically, by slicing up the data, Redshift can work on multiple parts of it at the same time. And that speeds up the whole process.
Makes sense. I've been hearing a lot about this Redshift serverless thing. How is that different from the traditional Redshift?
So Redshift Serverless makes things even easier. It gets rid of the need to manually provision and manage your clusters. It scales all your compute resources up or down automatically based on what you're doing. And you only pay for what you actually use.
So it's kind of like having a data warehouse on demand, right?
Mm-hmm.
It just scales to meet your needs and then scales back down when you're not using it. That sounds really cost effective, especially if you have data needs that are unpredictable.
Exactly. That's one of the biggest benefits. You don't have to worry about over-provisioning or underutilizing your resources. It just adapts to your workload and makes sure that you have the right amount of computing power available whenever you need it.
Okay, that makes a lot of sense. But where does AWS Glue come into all of this? How does that help build a data warehouse? Glue is a serverless data integration service. It acts like a bridge between your data sources and Redshift. It makes data preparation way easier. It can automate things like data discovery, figuring out the schema, and transformation.
So it basically helps get all of our data ready to be analyzed in Redshift. But can you give me like a real example of how it makes preparing data easier?
Sure. Imagine you have data coming in from all different sources, like your CRM systems, marketing platforms, and even website logs. Glue can automatically crawl those sources, figure out the schema, and even convert the data types to make sure it's all compatible with Redshift.
So Glue takes care of all the hard work, like the cleaning and the formatting, and that saves me tons of time and effort.
Exactly. It can handle structured, semi-structured, even streaming data. Plus, you can use Glue to make your data even better by joining it with other data sets or by adding calculated fields.
Now that is powerful. It sounds like Glue just takes care of all the hard work, the grunt work, all the stuff that you have to do to prepare data for analysis, and then it leaves you to focus on the interesting stuff.
Yeah. And because it's serverless, you don't even have to manage any infrastructure for it. It scales automatically to handle those tasks.
Wow. So we've got Redshift Serverless for a scalable and cost-effective data warehouse. And then we've got Glue to make data preparation simple. But how do we actually start architecting a data warehouse? Using all of this, where do we start?
Okay, so before we get into the architecture, it's really important to know what you want to achieve and understand the data you're working with. What questions are you trying to answer for your business? What insights are you hoping to get? And what data sources do you even have available?
You have to have a roadmap before you start building anything,
Right.
right? So once we know what our goals are and what data sources we have, then what?
Then you get to design your data model.
Yeah.
This is where you figure out how your data is going to be organized within Redshift. You'll need to decide how to structure your tables, what the relationships between them are, and the data types for each column.
So it's kind of like creating the blueprint for your data warehouse,
Mm-hmm.
making sure everything is organized logically and efficiently.
Exactly. A well-designed data model is really important for performance and to make analysis easy. It makes sure that your data is structured in a way that supports the kinds of queries you need to run.
I see. This is all starting to make sense. We define our goals, figure out our data sources, and plan out our data model. But then how do we actually get the data from those sources into Redshift?
That's where Glue's data ingestion comes in. Glue gives you different ways to efficiently load data into Redshift, whether it's from files in S3, streaming data from Kinesis, or connecting directly to databases.
So Glue builds those pipelines to move our data from all those sources right into our Redshift data warehouse. And can Glue also handle any transformations during that process?
Absolutely. You can actually define transformations within your Glue jobs to clean, validate, and enrich your data while it's being loaded into Redshift. That makes sure your data is good quality and consistent right from the start.
This all sounds super efficient, but I have a question about security. How do we make sure all our data is protected throughout this process?
Security is super important. AWS has a lot of different tools to protect your data at every step. We can use IAM roles to control access to AWS resources and make sure that only people and applications that are supposed to be there can interact with your data warehouse and Glue jobs.
So IAM roles are like digital security badges that give specific permissions to access different parts of the data ecosystem.
Yeah, exactly. And we can also use encryption to protect data both when it's moving and when it's stored. This is an extra layer of security that makes it really hard for anyone who's not authorized to access sensitive information.
That's good to know. We've covered a lot of ground already, but we've really only scratched the surface of how to architect a data warehouse with Redshift Serverless and Glue. I'm looking forward to going deeper into optimization techniques and those data modeling best practices in the next parts of our deep dive.
I'm ready when you are. We'll explore how to make your data warehouse perform as well as it can, and how to structure your data to make it really efficient. Welcome back. Last time we were talking about all the key components, Redshift, Serverless, and Glue, and how they work together in your data warehouse. Now let's dive into how to get the absolute best performance out of Redshift Serverless.
Sounds good. You mentioned something about distribution keys and sort keys before. Can you explain how those can really make a difference in how well queries perform?
Absolutely. Think of distribution keys as the way your data warehouse stays organized. They decide how your data gets spread across all those compute nodes we were talking about. Choosing the right distribution key can seriously speed up how fast your queries run, especially when you've got a ton of data.
So it's all about making sure the data is spread out in a way that optimizes that parallel processing.
Exactly. Let's say you've got a table with all your customer data, and you often run queries based on the customer ID. If you choose customer ID as your distribution key, Redshift will make sure that all the data for a specific customer stays on the same compute node. So when you search by customer ID, Redshift only has to check that one node. That makes the query way faster.
So we're basically avoiding having to move data around between a bunch of different nodes. What about the sort keys? How do those work?
Sort keys add another level of organization. They decide how the data is ordered within each slice on a compute node. If you often filter or join data based on a certain column, using that column as the sort key can really speed things up.
It's like making an index for your data, right? Redshift can find what it needs faster.
Exactly. Let's say you always check your customer data to find customers in a specific city. If you pick city as your sort key, Redshift can quickly find the right data in each slice. It saves a bunch of time and processing power.
Okay, got it. So distribution keys and sort keys are all about optimizing how Redshift gets to and processes the data. Are there any other ways we can tweak things to make it even faster?
Yes. Another really powerful technique is looking at query plans. Whenever you run a query in Redshift, it creates a query plan. This basically outlines how it's going to run that query. We can look at these plans to see if there are any bottlenecks and then optimize how the query runs.
So it's like looking under the hood to see how the engine's working and figuring out how to make it run better.
You got it. Redshift has tools that let you actually see these query plans. Then we can pinpoint areas that need improvement. Like we might see that a specific join is taking forever. Then we could optimize it by adding an index or even rewriting the query.
That sounds like detective work, but with some pretty big potential improvements. You also mentioned materialized views earlier. How do those help with optimization?
Materialized views are great for boosting performance, especially for those really complicated queries that you run all the time. They basically pre-calculate and store the results of a query. So Redshift doesn't have to run the whole query again. It can just grab those results directly.
It's like a shortcut to the insights you use most often.
Exactly. Let's say you have a really complex query that involves tons of joins and aggregations, and you run it every single day. Materializing that view can save you so much processing time.
That makes a lot of sense. But what if the data changes often? Do materialized views still work well in those cases?
That's a great question. Materialized views are best when your data doesn't change too much, but if your data is really dynamic, you'll have to refresh that view more often. And that can create some extra work.
So there's the trade-off there between the performance boost and the work of refreshing the view. Okay, I get it. Any other optimization techniques we should think about?
Well, data modeling is really important. How you structure your data and the data types you choose can really affect performance.
So now we're talking about optimizing the data itself, not just the queries. What are some of the best ways to model data that we should keep in mind?
One approach that works well is using a star schema. You mentioned it briefly earlier. It's like a star with a central fact table and then dimension tables surrounding it.
Right. The fact table is where you keep all the important numbers, like sales transactions or website visits, and then the dimension tables give you more information about those facts, like customer details, product info, or location data.
Exactly. Keeping those facts and dimensions separate makes queries easier and faster. If you want to analyze sales by region, you just join the sales fact table with the region dimension table. It's a structure that's easy to understand, especially for analysts who are familiar with the business side of things.
It makes sense to organize data based on how people actually think about it. Are there any other data modeling tips we should keep in mind?
For sure. When you're picking data types for your columns, think about storage and performance. Smaller data types, like integers for numbers or dates instead of using text, usually take up less space, and they can make queries run faster.
So it's about choosing the most efficient type for each job. What about compressing the data? We talked about that before with Redshift. Does it matter for data modeling too?
Absolutely. Redshift has a bunch of different compression encodings. They can really reduce how much storage you need, and they can make queries run faster. You can even use the analyze compression command in Redshift to get suggestions for the best compression encoding for each column. It looks at your data and tells you what's best.
That's cool. Redshifts can help us make better decisions about compression. Are there ever times when we might not want to use that star schema model?
Yeah, sometimes it's better to denormalize things for performance. Normalization is usually best practice in regular databases to avoid repetition. But in a data warehouse, denormalizing things can make queries easier because you don't need as many joins.
So it's a balancing act. Normalization versus denormalization. It all depends on what your queries are and how important performance is.
Exactly. And remember, data modeling isn't something you do just once and then forget about it. As your data grows and your business needs change, you might have to tweak your data model to keep things efficient.
This has been super helpful. We've talked about distribution keys, sort keys, analyzing query plans, materialized views, and even data modeling. Are there any other things we can do to make sure our data warehouse is running smoothly?
Oh, yeah, for sure. AWS has built-in monitoring tools that give you valuable insights into how well your Redshift cluster is performing. We can use system views to keep an eye on query performance, see how much of our resources are being used, and even spot potential bottlenecks.
System views sound like a great way to stay on top of things. What kind of info do we get from them?
You can see things like how long a query took to run, how much data it had to scan, and how much of your resources each query used. It helps you find queries that might be taking longer than they should, or using up too many resources. Then you can look into them and optimize them.
So it's all about catching those problems before they become big headaches. What other monitoring tools are there?
AWS also has CloudWatch. It's a monitoring service that can track a ton of different metrics related to your Redshift cluster. We can set up alarms in CloudWatch to let us know if we're going over certain performance limits.
So CloudWatch gives us another layer of monitoring and alerts. It helps us keep our data warehouse running smoothly.
That's the idea. When you combine system views, CloudWatch metrics, and all the optimization techniques we've talked about, you can make sure your data warehouse is running smoothly and efficiently.
This has been an awesome deep dive into how to get the best performance out of Redshift Serverless. I feel like I know way more about building a high-performing data warehouse now.
That's great to hear. Just remember, optimization is an ongoing thing. As your data and your business change, you'll need to come back and adjust your optimization strategies.
Yeah, that's true. It's not a one-time thing. It's a constant effort to make sure everything is running at its best. Welcome back to our deep dive on building data warehouses with Redshift Serverless and Glue. We've talked about all the different parts and how to make it run really fast. Now let's get into how we structure the data itself, which is data modeling.
Yeah, data modeling is super important. A lot of people don't pay enough attention to it, but it can really make a difference in how well your data warehouse works. A good data model makes your queries faster, and it makes your data easier to understand and analyze.
So it's not just about getting the data in there, it's about organizing it the right way once it's in the warehouse. What are some of the things we should be thinking about when we're modeling data?
One of the best ways to do it is to use what's called a star schema. We talked about this a little bit before. Imagine a star. In the middle, you have the fact table, and then around it, you have the dimension table.
Right, so the fact table has all those key metrics like sales transactions or how many people visited a website. And the dimension tables give you more details about those facts, like information about customers, products, or where things happen.
Exactly. Keeping those facts and dimensions separate makes your queries way simpler and faster. Let's say you want to see sales by region. You just join the sales fact table with the region dimension table. And it's a structure that makes sense to people, especially analysts who know the business really well.
It's like organizing information the way people think about it in real life.
Yeah.
Makes sense. Are there any other data modeling tips we should be thinking about?
Definitely. When you're choosing data types for your columns, you want to think about storage and how well it performs. If you use smaller data types, like integers for numbers or dates instead of text strings, it usually takes up less space, and your queries will run faster.
So it's all about picking the right tool for the job, right? What about data compression? We talked about that with Redshift before. Is that something to think about for data modeling too?
Absolutely. Redshift has a bunch of different compression encodings, and they can shrink your storage space by a lot. They can also make your queries run faster. You can even use the Analyze compression command in Redshift. It'll tell you what the best compression encoding is for each column based on your specific data.
That's awesome. So Redshift can help us make smarter decisions about compression. Are there any times when we wouldn't want to use the star schema?
Yeah, sometimes. Sometimes you might want to denormalize things to get better performance. Usually in regular databases, you normalize things to avoid having duplicate data. But in a data warehouse, denormalizing can actually make your queries run faster because you don't have to do as many joins.
So it's a trade-off,
Yeah.
normalizing versus denormalizing. It depends on what your queries are like and how much performance matters to you.
Exactly. And remember that data modeling isn't something you do just once and then never touch again. As you get more data and your business needs change, you might have to update your data model to keep things running efficiently.
This has been an awesome deep dive into architecting a data warehouse with Redshift Serverless and Glue. We've covered everything, from the different pieces to optimizing for speed, and even how to model data. What are your biggest takeaways from this? What are you struggling with when it comes to building your own data warehouse? Let us know in the comments below, and we'll try to answer your questions in future episodes.
And if you like this deep dive, hit that like button and subscribe to the deep dive for more deep dives into data and technology. We're always looking for cool new topics to explore. Until next time, happy analyzing.